Hello, this is Barry Evans with Penn State University. In this unit, we will discuss creating model input for the watershed simulation model included in MapShed that is called GWLF-E. To do this, we will be using a project that we created in the previous unit, Unit 3, called Demo. In terms of activities, we'll be using MapShed, that existing project that we created, to process various data sets for the purpose of creating an input file or multiple files that can be used by the GWLF-E model to simulate hydrology and loads for one or more watersheds. This is basically a very simple process. We first open up an existing MapShed project, in our case Demo. We then select a watershed or one or more watersheds for processing, and then we initiate the processing. And when the processing is done, one or more input files are created for the model. So the first thing we want to do is open up the existing file that we created called Demo. You first go to your MapShed icon on your screen, double click on that. Remember, before we built a project, this time we're going to open an existing project called Demo. Go to our pull down list, select, in this case, Demo, and then say Open. MapShed will then open up that project and load all the layers for that particular area, in this case the demo area for the Spring Creek watershed in central Pennsylvania. If you wish, you can turn on different layers to see what's underneath. That's not necessary to actually create data. The data sets are already loaded. Basically, what we want to do, I will turn on the streams here first. What we want to do is use this button right here called Select Basins. That's the first step in generating an input file. We click on that, and we click on a basin. Or we can use a box to drag to select multiple basins. In MapShed, you can create an input file for a single basin. You can create it for a combination of basins. In this case, I can do one of two things. I can dissolve the interior boundaries here and treat it as a single basin and generate one input file for the larger basin comprised of these three smaller basins. Or I can generate three separate input files for each of those three separate subbasins. I can run those independently with the GWLF-E model. So we will do all three of those as part of this particular unit. So first, let's just select the one basin. Once it's selected, the next step is then to use this button called Create GWLF-E Input. This initiates a process whereby these different data layers you see in the left-hand side of the screen are overlaid and combined in different ways to estimate input parameter values for different parameters used by the GWLF-E model to simulate hydrology and pollutant transport. Anyway, so once this is selected, we then say Create, and we are presented with this screen. What MapShed has done, it has looked at the nearby weather stations and has said, well, you've got data ranging from 1975 to 1998 in this case, but that may change depending on where you are in the state or your particular region. In this case, we've got data for at least two weather stations that span this range. What we then do, and I will just choose 1989 through 1998. You have to specify first a period of simulation. You can choose all the years if you wish. If you want to change your selection, just click on one of these. I will start from the beginning, so I'll say 1975 to 98. What I'm interested in here is just to see what the average load is that coming from this particular watershed with rainfall that's similar to what's seen in that particular period. And if you're doing calibration, it's more critical that you pick specific years. Although in this case, we're just interested in generating rainfall on this landscape for a long enough period to be more or less representative of what is occurring in that area. After we've chosen the weather years, we then select the growing season. In this case, it's more or less specific to the crop season. In Pennsylvania, we can say a typical crop growing season might be from May to September and May to October. We'll choose May to September. You then, if you've chosen more than one subbasin, you would have to say whether it's aggregated or not. In this case, it's only one basin, so it tells you that an aggregate is only performed on 2 or more, so we say OK. So we've only selected one. We'll see later on that what happens when you use the aggregate mode. As far as this is called a slope length method. This is to help calculate erosion, eroded loads from landscape. We have 2 options, but by default we use flow accumulation. I won't go into the details, but it's really the best one to use. In MapShed, if we've loaded a septic system layer, we can choose to use that. In this case, we did not. Rather, we're going to use the land cover map to estimate the population on septic systems. So this is the default choice, and we will leave it at that. For those interested in how you might change some of these values and why you might do that, there's information provided in the user guide on that. We will skip this part right here where you're asked to specify a fraction of irrigation water that comprises subsurface flow, return flow, but that's only if you deal with irrigated crops, and we're not in this case. So the next thing you need to do is specify an input file name, the name of the file that we're going to create. By default, this input file is going to be put into a directory called run files. Now we can choose to turn this off, which means if we give a file name here, we're going to be asked where's the folder you want to put that in. And you can put it really anywhere you want to. To make it easier though, in this case, I am just going to have a folder automatically be called the same name as the input file that we're going to create. I'm going to give this a name, demo. I'm going to call it single, because I'm just doing a single watershed. We're going to change that in a later run. But anyways, we'll go with that for now. Once we've made those selections, we then say OK. And you get a screen that tells you that it may take a couple minutes to process this basin that we've selected. In this case, though, this should run pretty quickly because it's a pretty small subbasin. So we will say yes. And what is happening? MapShed is looking for the weather data. It then starts clipping, and you see some of the processing that's done below here. It's clipping the streams, the land use, it's overlaying things, and you get a process bar here on the right. When this goes all the way to the right, it's completed. But basically, it's doing all the overlaying and processing, pre-processing necessary to create the input file for this particular subbasin. And it's done. That took about 34 seconds. In MapShed, the processing time is directly related to the complexity of the data layers and the size of the watershed that you've selected. So you may find that 30-40 seconds is, let's say typical, but it's not unusual to have processing last as long as 3, 4, 5, up to 10 minutes in very complex situations. So I'm going to say OK here, and then we'll take a look at what's happened. I'm going to minimize the screen. I'm then going to go into the project manager. I should say the go into my Windows manager here, and I'm going to take a look at what's happened. Underneath, see, in MapShed, I've got lots of additional files that you won't necessarily see, but under MapShed there is a folder called Run Files that things are written to by default unless you choose to do otherwise. So under Run Files, I also have multiple files, but I have one that I just created today, this one called Demo Single. And what has happened, this has just been created. It's called demo single, and it has a number attached to the end of this. This number is directly related to the ID that's given for that sub-basin in the GIS data layer. So let's take a look at that. I go back to my screen, and if I look at the basins, I'm going to open up a table here, and I see that each of these basins in this have an ID. This has one called 7238. That's the one that's been selected. That is the number that gets attached to that input file that we have just created. So this helps you track, or at least relate, the input file to the basin, because that number is the ID number that gets appended to the end. Okay, so that's it. That's how you create an input file for one basin. Let's move on to a more complex situation now. Okay, in this case, I'm going to use the select button, and I'm going to draw a box around these three over here. What I can now do, as I said, I can create an input file for that combined watershed, and MapShed dissolves those interior boundaries and just creates one watershed. In this case, that trailing number for the input file will be 0. So whenever things are combined or aggregated, the input file has a 0 appended at the end. Now, I can also run these as independent watersheds. Now, in this case, that number, that trailing number at the end, will again relate to that ID number that's shown, that's given for each of those sub-watersheds in the basin's layer. Now, if you're interested, you can actually add the labels on the screen. So if I hit the Add Labels button here, and I choose ID, and say Create Labels, it actually pulls the IDs from the tabular associated table to basins and displays those IDs. In this case, the first one we created input file for 7238. In this case, we're going to create first an input file for all three of these. Now, the way I do that, I've got the basin selected. I then say Create Input File again. I will choose all of the weather years as I did before. I'll say May to September. In this case, I will give it a, I'll say, demo combined, to show that all of those watersheds have been combined. So there will be a new folder created called demo combined, and the input files will also be created, called that as well. So I say OK, and then I say yes. Now this may take just a little bit longer than the one before. The last one, it took about 34 seconds. In this case, it had to first dissolve those boundaries, those interior boundaries, and then do the same search for nearby weather stations, and now it is clipping and combining and basically massaging all the data underneath these watersheds in this area that we've already loaded. So it's working on the soils right now. This should be done in just a couple seconds here. The last step, as you may see, it says writing input files. Processing is done. This took 58 seconds compared to 34. Now let's see what's happened. I'm going to minimize this. And again, look under the Run Files directory under MapShed. In this case, I've got a new folder called Demo Combined. And the input file is called Demo Combined as well. And this now has a trailing number 0. That means that there are one or more watersheds that have been combined, and this is what you always see with an aggregated watershed. Okay, one more. Let's go back to our demo, and in this case we use our Select Basins button. I'm going to choose those same three, and then I'm going to say Create Input File. I'm going to choose the same weather years, May to September. In this case, however, I am going to say don't aggregate, say no. So this means that each one of those are going to be treated separately, and a separate input file is going to be created. So in this one, I'm going to say demo multi, I guess, for multi-basin. I will then say OK. Yes, I want to proceed. This one will probably take a minute. What's happening is that it will do clipping and processing on each of these basins independently. So the first one it's working on is 7222. When it's done with this one, it'll then move on to the next one. So it's now moving on to 7276. So we should be about halfway done at this point. Okay, it's now moved on to the last one, and it's done. So that took about a minute and 17 seconds. Okay, again, I will minimize this. Go to the Run Files directory, and we now see that we have another one called Demo Multi. And in this case, we have a separate input file for each of those three subbasins that were in that larger area that was selected. So now that we have created the input files, we can now view these, we can edit these, or choose not to edit them, and then run the files to create some output with the GWLFE model. And we will do that in the next section. All right.